Okay, so let's have a look at the Leaving Certificate Higher Level Paper, Maths Paper 2 for 2019, and we're going to have a look at question 2. So here we have a line P, so we have it here, and it intercepts the x-axis at a is 0 and the y-axis at 0b. A and b are not 0. So we've got to show that the equation of P, that the equation of this straight line here, can be written as x over a plus y over b is equal to 1. Okay, so let's do that. So in order to find the equation of a straight line, normally we would use this formula here. And what we need to put into this then is a point and the slope. So we're going to need the slope of this line as well, so let's just do that over here. So we need the slope, which is just the difference of the y's divided by the difference of the x's, rise over run if you like. So y2 minus y1 over x2 minus x1. Now we have 2 points here. We have 0b and we have a 0. So we'll just call them x1, y1, x2, y2. Substitute them in here. So we've got 0 minus b divided by a minus 0. And that will just give me minus b over a. So our slope, the slope of this line here, the slope of any line that intercepts the x and the y axis, where the b and a are not zeros, it's just going to be the minus b over the a, So let's put that in here and see where we end up. Now we have y minus, now we also need a point, okay, so I'm going to use the point a0. It doesn't really matter which one you use, but let's use a0. So I'm going to say a is my x1 and 0 then is y1. The m here we've decided, or we've worked out, as being minus b over a, and then we have x minus, the x1 in this case is just a here. Okay, so let's work this out then. Y minus 0, that's going to be y. Now I'm just going to, I'll actually do that on the next line. I'll just leave that as it is, x minus a, and what we'll do next is just multiply across by a, because we've got an a as the denominator here. So on the left hand side we get ay, over here we have minus b times x minus a. Now I'm just going to multiply out this bracket here, so we've got ay is equal to minus bx plus ab. Minus times minus is plus, a times b is ab. Okay, so we're on the way here anyway, so we're almost there, I think, at this stage. Now you've got to look at where you want to end up. So we want to end up with this thing up here, this here. So we need a 1 on one side of the equation, and we need an x over a and a y over b on the other side. Now let's just have a look here. We have an ay here and we have an ab here. Now the problem is, on one side of the equation here we need an x and a y, but here we have a y on this side and we have the x on the other side. So what I'm going to do is just take this here and bring it over here so that I'll have the x and y on the same side. So I've got ay here plus bx, and that's going to give me ab. So now I have the x and the y on one side, I have an ab on the other side. So in order to get this 1 here, I'm going to divide everything by ab. So if I divide, I'm going to divide this, this, and this by ab, each term by ab. So divide the left hand side by ab. So divide this by ab, ay divided by ab. So really what I'm doing is ay divided by ab. Well, the a's will just disappear, or they'll divide to give me 1, so I end up with y over b. So here I'll end up with y over b plus, take the bx take the bx, divide that by ab. Well, again here the b's will disappear here this time, and I end up with x over a. And divide the right hand side by ab, and I'll just end up with 1. And that's exactly what we needed to show then. We started with the equation of, this was the equation of the straight line here, and we just manipulated until we got where we wanted to end up. X over a plus y over b is equal to 1. I'll just rewrite this just so that we have the x over a first plus y over b is equal to 1, and that's it. I think that's all we were required to do. Show that the equation of p can be written as, and we have. Okay, so that's it. Now, next part to this question is part B1 here. Now we have the line L has a slope m and contains the point 6, 0. So this is similar to the question that we had above. We have a line that kind of comes down like this, but this time we're told that this point here is 6, 0. So our a here is 6, if you like. We don't know what this point here is, just 0b, 0 some other number anyway. So anyway, we have write the equation of the line L in terms of m. So let's do that. Well, again, this is a straight line, so we've got y minus y1 is equal to m into x minus x1. Now in this particular case, we know that we have a point here which is 6, 0, 6, 0. So it says write the equation of the line in terms of m, so we don't have to find a slope here. So I'm just going to write y minus, and the y1 here in this case is 0, that's our point here, 6, 0. M we're leaving as m, and then we have x minus 6 here. So that will give us on the left hand side y is equal to mx minus 6m. And that's it really. That's writing the equation of L in terms of m. This is our line L here. Now there is another way you could do that. I mean, you could start with where we finished the last section there. We in part A there. This is part B, by the way. I think this is part B. So we finished with I think it was x over a plus y over b is equal to 1. So let's see, do we end up with this as well if we do this method here. So this is where we want to end up. Let's see, do we get the same answer? Well, let's just work backwards a bit. Let's multiply everything by ab first. So if we multiply this by ab, we get bx. Multiply this by ab, we end up with ay. Multiply this by ab, we end up with ab. So for example, x over a times ab, the a's will just cancel here and we end up with xb. So that's where this came from. You can do the same for this one, and ab times 1 is just ab. Okay, so let's get the y on its own here, because we want it to look like this here. So we end up with here ay is equal to let's see, minus, well, we'll say ab minus bx. Next thing we've got to do here is just divide across by a. I want to get the y on its own here, remember, so divide across by a, so we end up with y is equal to so we're dividing across by a, so if we divide ab by a, we just end up with b. Divide this by a here, we end up with minus b over, oh sorry, I'll just go back a bit here. So we're dividing by a, so we just end up with minus b over a x. Okay, so now in this particular case here, we haven't quite gotten to this format yet, so let's see if we can manipulate this so that we end up with that. Let me see now. We have a b here and we have a b here, and an a in fact that we don't want. So if you remember from what we did in part 1, if you take we go back up here again, if you remember any particular straight line like this where you've got a 0b and an a 0 here, the slope will be, m will be minus b over a. So the slope will be minus b over a. So this is what we're looking at here. So the slope m will be minus b over a. So that's what I'm going to use next. So if we take m is equal to minus b over a, multiply across by a here, that will just give you am is equal to minus b, or in fact b is just equal to minus am. So I'm just going to use this here and substitute in here for b and see what happens. Okay, so actually I'm going to have to move over a little bit here just to, we'll come over this direction here. So my b here is just minus am. So I'm going to rewrite this here. So we have y is equal to b minus b over a times x. But we know that b is minus am, so that will give me y is equal to minus am, because I'm just substituting here b for minus am. Do the same here, so but there's a minus am is on the top, I've got an a on the bottom, and I have an x here. So let's just see where we end up here. So we got y is equal to minus am. Here we have this minus minus is plus, so I'm just going to put a plus in here. That a will cancel with that there, or divide by that a there, and we end up with mx. So in other words, we end up with y is equal to mx minus am. Now, this is where we want to end up here, remember. We're almost there. Y is equal to mx minus am. Y is equal to mx minus 6m is what we got here for this particular question, because remember that our a in this case is where it cuts the x-axis, and it cuts the x-axis here at 6, 0. So our a in this particular case is 6. So all I've got to do here is just rewrite this as y is equal to mx, or a is 6. So this is where I end up. If I do it, this is kind of a longer way of doing it, but y is equal to mx minus 6m. Y is equal to mx minus 6m. So both methods will give me the same equation of this particular line. Okay, so let's look at number 2 then, part 2b. So we have another line L, and it cuts, the line L that we worked out in part 1 cuts a line K here, which is another line, 4x plus 3y is equal to 25 at a point P. Find the coordinates of P. So this is really a simultaneous equations type question. So we have two equations here. We have y is equal to mx minus 6m. That's our line L. This is our line L here. And we have the line K as well, and we're told that's 4x plus 3y. 4x plus 3y is equal to 25. So these are our two lines. What we've got to do is find the point of intersection of these two lines. Now the point of intersection of these two lines we can just work out by doing, as I say, simultaneous equations. So let's write these out and just work our way through it. Now it says give the coordinate as a fraction in its simplest form, and we've got to give the coordinates in terms of m. So let's see, we're going to start with, let's write down 4x plus 3y is equal to 25. We'll call that, let's say, equation 1. Now over here we have, I'm just going to rewrite this. I'm going to take this mx and bring it over this side. So we have minus mx plus y, and that's equal to minus 6m. And this is equation 2. So these are the two equations I'm going to work on to find the point of intersection. So let me see. What I think I'm going to do here is just try and get rid of the y's here. So I'm going to take equation 2 and I'm going to multiply that by minus 3. So if I do that here, I'll get minus minus is plus, so I'll end up with 3mx minus minus is plus, 3 times mx is 3mx, Minus times plus here is minus. 3 times y is 3y, so that's minus 3y. And here I end up with minus minus is plus, 3 6s 18m. Let's just write down equation 1 underneath that. So equation 1 is 4x plus 3y is equal to 25. Now I'm just going to add these two equations. So here I have 3mx plus 4mx, so that's just 3m plus 4 times x. I've just factorized out the x here. Okay, here I have a minus 3y plus 3y, so that's going to just give me 0 when I add them. That's why I multiplied by the minus 3 here in the first place. And on the right hand side I end up with 18m plus 25. 18m plus 25. Okay, so now I can find my x coordinate. So my x coordinate here, that will just give me x is equal to 18m plus 25. I'm just going to divide that by the left hand side here, what I had on the left hand side, the coefficient of the x here, which is 3m plus 4. So this is my x coordinate. So that's the first part of my answer here. Okay, I don't think I can simplify that anymore. I can't divide the top and the bottom by anything in particular. I can't factorize. So that is it. So let's work on y now. So we've got to find the y coordinate. Now I'm going to take the equation 1 here. 4x plus 3y is equal to 25. I'm just going to substitute this in for x. So I'm going to put x in here. Okay, so let's work on that then. So we have, let me just write that down first here. So we have 4x plus 3y is equal to 25, and this is equation 1. Okay, now let's just substitute in this here and see where we end up. Okay, so we have 4 times, we have 18m plus 25 divided by 3m plus 4. We have the plus 3y, and that's equal to 25. So really all I've got to do here is isolate the y. So I want to end up somewhere down here with y is equal to, and hopefully I'll just end up with some fairly simple fraction, relatively simple fraction anyway, with an m in it, which I should do. So let's just multiply all this out. Let's see, 4 18s, well that's going to give me 72 m plus 4 25s, that's 100. The bottom remains the same, 3m plus 4. Have a plus 3y, and that's equal to 25. Okay, now I want to get the 3y on its, or the y on its own, so I'll get 3y on its own first. So that'll give me 25 minus 72m plus 100 divided by 3m plus 4. Let's keep going here. I'm just going to divide by 3 now. So divide all the terms by 3. So divide this by 3, I'll end up with y. Divide 25 by 3, it's 25 over 3. Divide this by 3 is just the same as, if you like, multiplying by a third. So multiply this fraction here by 1/3. So I'm going to end up multiplying the denominator here by 3. So the numerator will remain the same. The denominator multiplied by 3, so that will give me 9m plus 12. Okay, let's keep going. Now this is our y coordinate here, but it says give your coordinates in their simplest form, so we've got to kind of simplify this. So the way I'm going to do this is add these two fractions here. So I need a common denominator here first. Now if you notice here, we have a 3 here and we have a 9m plus 12 here, which is divisible by 3. This is divisible by 3. So my common denominator here is going to be 9m plus 12. Divide 3 into 9m plus 12. So if you imagine 9m plus 12, and we're just going to divide it by 3. Well, 3 into 9m is 3m. 3 into 12 is 4. So this is what I get. When I divide 3 into 9m plus 12, I get 3m plus 4. Multiply the top by 3m plus 4. Okay, so on this side now, 9m plus 12 into 9m plus 12 is 1, so I just end up with minus the numerator here, which is 72m plus 100. Now you got to watch this minus here. This minus is going to change these signs here. Okay, next we have y is equal to, well, 25 times 3m, that gives me 75m. 25 times plus 4, that will give me plus 100. Minus 72m minus 100. Minus times plus is minus, so that's minus 100. On the bottom I end up with 9m plus 12. Okay, so let's see, we have 75m minus 72m, so that will just give me 3m. Plus 100 minus 100 will give me 0. And on the bottom I end up with 9m plus 12. Okay, and finally I can see here that I can divide the top and the bottom by 3. So divide the top by 3, I'll get m. Divide the bottom by 3, well, 3 into 9 is 3. 3 into 12 is 4. So this here is my y coordinate. So that rather complicated looking fraction at the beginning here did simplify quite well. So my answer then is, what way did they actually put the question here? The line L cuts K at the point P. Find the coordinates of P in terms of M. So my final answer then is just going to be P. Oops. P here is just going to be equal to 1 second now, I should have this. Okay, so let me just write that out if it works for me. Ah, there we go. P is equal to, okay, finally. So the point P then is just going to be equal to 18m plus 25 over 3m plus 4. 3m plus 4, that's the x coordinate, and the y coordinate then is just m over 3m plus 4. And that's it for this particular question.